Good afternoon, everyone. And this is the first time in the public conference. And this topic is actually my thesis master degree. And the topic is about forensic analysis of Android banking apps. The agenda for today is introduction, related words, research methodology, experimental results, conclusion, and reference. According to the news, I'm from Thailand, and I have a latest news at the end of the last month with a man who has a business about car accessories, and his business can be conducted via online. So one day, they have fake customer, have a chat via Facebook with him, and make a purchase order, and also they ask for his identity, like a citizen ID, and also the account number to transfer via Facebook. But that fake customer use that fake identity to the mobile operator and ask for new SIM card. And he say to the mobile operator that he lost his purse and also lost his mobile phone, so he prefer to get a new SIM card and use that SIM card to make a phone call with a financial institution and to ask to reset their password to access the mobile banking apps. And after that, they can conduct transaction money transfer from the owner banking account to the malicious account around 1 million baht, and the remaining account is just only the 50 baht in the account. And so it's important to say that banking apps should be investigated in terms of forensic analysis, because this eventual data could be used to track the user identity or any transaction that can be performed on the banking apps. And this research question is about how much sensitive user data and also app-generated data can be stored on the mobile device, such as registration ID or citizen ID, and also banking transaction that can be conducted in the banking apps. And also, I perform the application code analysis in terms of reverse engineering to modify the code and also repackage the app to be installed on the another device and see how many traffics can be intercepted between the application and also the application server. And from the cursory literature reviewed any paper, we can see a lot of social networking apps and also some mobile apps like mHealth apps that can have a forensic investigation. And this paper provides me about the principle of performing mobile apps forensic investigation and also how to locate the evidentiary source of the data. And also this can be used to be the guideline for the conducting the application code and also repackage app to see how security mechanisms on the app are function. And in our experiment, we performed the forensic investigation on 2 phone models. The first one is actually this model is a Galaxy S4, but on the left-hand side is a Galaxy S4, and the right-hand side is a S4 Mini. But I used the physical acquisition to acquire the forensic image. We are on the left is the rooted device for DD method to create the entire flash memory. And the right side, I use the JTAG method to acquire the image also. And the result from this method have a little bit discrepancy. And I prefer to anonymize the bank account name because some banking apps in my country don't have updated version. And I perform the banking apps on 7 financial institutions in Thailand. Let's name Bank A, B, C, D, E, F, and G. And the transaction that I perform is balance inquiry, money transfer, calendar or remind setting, ATM search branch, and the last one is a bill payment. And all activities use my own account, and the activity has performed just once. You see, actually, all 7 banking apps can perform the common activities, but on the Bank A can perform the calendar setting. And you see the reminder setting that in the database of the app also. And for the forensic tools, I use the common forensic tool to acquire the image, analyze the image, and also application code analysis like FTK imager, autopsy, and also JDGUI APK tool, and to decompile the code and analyze it. And in my research, there are 3 image acquisition. The first one is obtain image via JTAG, and second one is obtain via DD method, and the last one is a logical acquisition technique to acquire image via smart switch backup, like when you connecting with an Android device. And to be conduct an image acquisition via JTAG, you must first check that phone model has a JTAG pin or not. If it has, you can search via in the internet and find the pin by dismantle the device, and also serializing the wire behind your phone and with the JTAG box. In this term, I use leaf box to create the image. After that we have finished with serializing, we can turn on the phone and obtain the image. If it cannot perform with the JTAG, you can use a DD, but the device must be rooted, and also USB debugging must be enabled, and you can get the same physical image with the JTAG. And the last one, if the physical image acquisition cannot be performed, you can use a logical backup to back up the folder and the data on the device. And you can see just only the file system content, but not the deleted data that will be located in the unallocated space. That can be gained when using physical acquisition only. And the forensic analysis, I will drill down to the data partition in each application folder. And the most forensic artifacts could be located in this location. Like, for example, when you see in banking apps, you see the web view or preview, application database, SharePoint files that keep about the configuration files in terms of XML. And I found so much data on this folder, SharePoint file. And application database that's normally kept in a form of .SQLite or maybe .db file. And you see some crucial information on that also. And the Picasso or Wedge view, you can see like a user image that can be uploaded via the application, and maybe some transaction, like a transaction receipt when you finish or complete the transaction. Like a money transfer or bill payment, you got a automatically receive picture. And for the database folder in the SMS, you can see the transaction when you have a money transfer or bill payment from one account to another account. You can use that reference number to be confirmed or verified check back to what date that transaction was performed. And this is the analysis results that I can be performed. According to the table, you see that Bank B, Bank C, and Bank E kept the receipt picture and timestamp. The timestamp in this term is used is kept in Unix epoch format. So when I analyze, I must use the epoch converter to convert back to my local time, GMT +7 in Bangkok time. And this can be shown that in the receipt picture, you can see that what amount that can be transferred, and also what date to the account and source destination account in what date that can be done. And this is also, it can be from the table, it can be shown that money transfer left the most forensic artifacts more than the other activity. And this is a sample of the SMS content after I finish my transaction. you see the reference number, OTP value, and the source account and destination account, and the amount number. And I highlight it because it's my credential data. And this is also for the Bank E and Bank F that I highlighted is because it can be kept citizen ID that's in nation is a national ID that in my country is private information. And also the credit card number, date of birth, that three information can be used to acquire the data or apply for the application in my country and can be used to confirm your identity in any transaction. So it should be kept in private. And from this table, it can be shown that the most powerful artifacts can be found in the SharePlay folder that I previously said before. And also, the transaction can be used to identify and confirm which are the telephony database in SMS. When you see in SMS content, you can use that data to confirm with the receipt picture that transaction can be occurred on that date. And this is a logging form from Bank F that show the my citizen ID, credit card number, date of birth, and also mobile phone number. This data can come from when I apply the application via the banking app, not only register to the ATM branch or any ATM machine. I can apply the application via the banking apps and fill the information that they ask me. Actually, all 7 banking apps ask the same information to fill out when apply the app. And this is the only one application that kept the data in the log file after the first time you register to the app. And it's so scary with me. And after I finish with the forensic analysis, I go beyond to the application packet analysis. I use the same common technique to extract the app in APK file, rename to the .zip, and unsave it and convert it to the .class file by using the toolbar and then display it with the JDG UI and analyze that code. After we analyze the code, I categorize the application into features like application features and also security mechanisms. For the application features and the share library, you see like when you extract the folder, you see a folder name, a lib, and inside that folder, you see the library name that are used by that application to call via third-party app or also produce their own app. And also the share component like activity, receiver, or service. And also the web service. Web service in this term use HTTPS via port 443. And the user registration means the basic requirement information that asks for when you register to the app. And also the session timeout, I try to not touch the app, not conduct any transaction and leave the phone out. After the idle time, the app could be logged out in how many minutes that can take that to log out. And for the security mechanisms, I found the root device detection like in the code. There we have some method or class that check for the /system/bin or /su to check there is a super su like application on the phone or not. And some application could be show the screen to ask for or remind the user that after this, when you click that button, you will conduct the transaction with the router device. So I think this feature is more important to remind the user what's going on after you run or conduct transaction with the router device. And also the encryption, almost many of the app implement the encryption method, but some have a built-in but not called it. And also for the certificate pinning, it's the most popular that is implemented in a banking app in Thailand now because it likes to protect the interception of the man-in-the-middle attack and also not trust the device store, just only trust the certificate that come from the server. And also the authentication some applications implement the like a Pro card that are open source with the Android, and also it makes me harder to read that code. And the last one, signature authentication. All the applications have a signature to be protect the illegitimate updates of the app. And this is my results from the previous table. And it will show that for the web service, Bank D could have a code URL to link to the web service. When I copy that URL onto the browser, it will show the server banner of that application server. And for the Bank E, it's the only one app that have a service component, but service component is named like a logout service that not show any sensitive information. And the user registration information, actually all the 7 banking apps ask for that information like the same for the citizen ID, ATM card or debit card, and date of birth, and allow you to set your username and password. And from this can be summarized that Bank E does not import the third library, but is the only app that have a service share component. And after we finish with the security features, we will look in our security mechanisms as shown in the table. You can see that Bank A, Bank B, Bank D, and Bank E implement the certificate pinning, and the only one A and B can implement the code authentication. So the remaining 5 applications, you can extract the app and read it in a human readable format. And actually, it can be said that nearly half the banking apps implement the basic security features that used to be in banking apps, but it can be reduced to the attack vector when any malicious guy prefer to exploit the app. And when I use I use the burp proxy to third-party certificate to force install in my own device, and can intercept the traffic between Actually, I use the device and set the proxy to my burp, and also when the application runs, the application will pass my intermediate proxy before go to the application server, so I can see some information like password or PIN 6 digits when you log into the banking apps, and also some username and credential like citizen ID when install traffic. By install traffic, I can use ADB logcat that are built-in command with the Android. And when you launch the app and run on crawl any menus, you can see the what's going on, what the activity can be called, and also the data that can be transit between that. And for the Bank D that I highlight it, this is the only one application that I can I reverse the application and see the check server trust method. This is normal for banking apps to implement certificate pinning, and normal for every application. But this is the only leaked information because this method uses only for loop to check the certificate, and we can bypass it by using a comment out on that line, and also remove the old version of the app and install my new version that have my self-signed certificate on the app and run it. After I run my fake app, I can see the username, password, and also any sensitive data like when I make a bill payment, I can see the amount. All information in this Bank D is clear text, not have encryption. Although this app have a built-in encryption, but it cannot be called. And also in this application, I can use the same session ID to be logged in to another device. And although this session has a short time, but during that short time, I can use that session ID and copy paste to another device and log in to perform any transaction. And also in the Bank E, Bank F, and Bank G, I can perform the SSL inception, but the data is so less than the previous Bank D. just only the clear text password, but not include any banking transaction. And this is, for example, from repackaged app to innocent traffic of BankD. You can see on the highlight yellow is 6-digit PIN in clear text. And in terms of security, this is important data because if anyone try solving you when you conduct a transaction, you can use that PIN and use that PIN number and log into the banking apps and conduct any transaction like money transfer or bill payment. And for the summary of this research, we can say that application code analysis, Bank A, Bank F, and Bank G do not implement the root device detection, like have not method about to check the system library or system soup. And also Bank D, Bank F, Bank G have a built-in encryption but not call that. And for the application, the packaging analysis, I can install the fixer on 4 apps like Bank C, Bank D, Bank F, Bank G. And the Bank D is only one app that can see the sensitive data and bypass SSL pinning. And also use the same session ID to log into another device. And this is my reference. Jay.
Yes.
Hey, that was actually really quite a shocking talk, just how many issues there are. So looking around Southeast Asia, though, most other countries, here Singapore included, have regulatory requirements for financial institutions to follow. So MAS here requires that banking applications have or don't log the sensitive information that you noted. They use things like SSL pinning. What does Thailand have exactly?
Actually, this thesis started on the last December last year. And I go on to updated version of the app, and some application I have a chance to have a penetration testing with that, and also they have fixed some vulnerabilities, don't leak information like in the presentation. But around half of the application still remain.
The governments aren't enforcing the banks to do this?
In Thailand, they have a policy to meet the requirement of PCI DSS, but
That's it?
It's hard to perform. And one of the, in my experience, one of the application implemented, but don't achieve it, just only during implementation.
Well, that's actually quite sad, because it's not that hard to perform. I mean, Hong Kong does it, Singapore does it, Malaysia does it. Okay. Sorry, thanks.
I think my question is very straightforward. The research that you did for the banks, right, is it local Thailand banks or foreign banks that also resides in Thailand? Are those banks that you researched are all Thailand banks or
Yes,
foreign banks?
Only Thailand banks.
Only Thailand, okay, that's all. Thank you.
And this is done on the unencrypted device. So if I found encounter with the encrypted device, I must use the other techniques to dump the data and analyze it.
All right, so any more questions from the floor?
When you do the analysis on the banking apps, how many apps that you require to use JTAG interface to take out the stuff?
Okay, I use the JTAG for all 7 apps, and also DD also.
Okay, thanks.
All right, thank you. Any more questions? So I presume there's no questions. All right, thank you. Thank you very much.